Okay, start chapter 4. We're going to start out with polynomials, and we're going to start with a monomial. So a monomial is a number like 8 or negative 3/4, a variable, say x, or a product of a number and one or more variables, like negative 3x, 4x to the 5th. You could do x to the 6th, y to the 7th. You could do x cubed over 3 because that's the same thing as 1/3 x cubed. Like, all of these are monomials. They have to have whole number exponents on the variables, and you have to have a real number out front. Now, a polynomial is a monomial or a sum of monomials. So, like, this is a polynomial, but it's also a monomial. If you add, and monomials are things that most of the time we refer to as terms. And terms are stuff that are together with pluses and minuses. It's like 2x plus 8 has two terms in it, a 2x and an 8. But 2x is a single term because it's a product. Anything you have that's a polynomial function is going to be in this form right here, where a sub n minus 1, a sub 1, a sub 0, which people call a naught, which is really saying naught, but it comes out not. That's just your coefficients. Like, whatever the biggest power is, n, then you're saying that's the coefficient that goes with the power with n on it. And then the next term, a sub n minus 1, is x raised to the n minus 1. And the coefficients can be zeros except for the lead one, because whatever's out front, it can't be a zero, or you wouldn't call it a polynomial that degree. I actually hope nobody's listening to this, because I just keep stopping and starting. I must be tired. All the exponents are whole numbers. And remember, whole numbers are 0, 1, 2, 3, etc. Coefficients are all real numbers, so none of the coefficients can have imaginaries in them. And whatever that, when you put it in descending order, whatever that first coefficient is, we call that the lead coefficient. The biggest power is the degree. Here it's the n, because it's the one with the biggest power. The a naught is the constant term, because it's saying like you got x to the 0. Nobody needs to see an x to the 0, because that's 1. Polynomial functions in standard form when it's written descending order, the exponents from left to right. You usually probably just call that descending order, which is what I always called it when I was a kid. We've already talked about linear functions. We've talked about quadratic functions. Linear is when the biggest power is 1. It's x to the first. Quadratics when you have x squareds. We've talked about constant functions. That's when you don't have an x. It's like y equals 7 or something like that. And then if the biggest power is the third, it's a cubic. And the biggest power is the fourth. We call those quartics. That's just an example of each. So it says decide whether each polynomial or each function is a polynomial function. If so, write it in standard form. State its degree, type, and leading coefficient. All right, so here's the thing. All the coefficients are real. Okay. All the exponents are whole numbers. And it's a sum of a bunch of monomials. This is definitely a polynomial function, and it's in descending order. So this is standard form. The degree of this one, biggest power is 3. This is a cubic. Oops, hang on, sorry. The degree is 3, which therefore we refer to it as a cubic. And then the leading coefficient is a -2. Now, a lot of times I'm going to say lead coefficient because that's what I've always called it, but you can say leading coefficient. Now, just in case they'd ask, the constant term on this one was the 8. But it didn't ask for that. It just said write it in standard form, which it already was. Give me the degree, and therefore what type it is. The degree is what makes it called a cubic. Let's see. This next one's not in standard form, but -0.8 is a whole, oh my gosh, a real number. The square root 2 is a real number, and a -12 is a real number. And the exponents are 3 and 4, both whole numbers. This is a polynomial function. If we wrote it in standard form, we'd have to put the x to the 4th first, and then the x cubed, and then the constant term. So the degree of this one is a 4, which therefore that makes it a quartic. And the leading coefficient is the square root of 2. If somebody asks for the constant term, it is that negative 12 on the end. All right, this next one is not a polynomial function. And, well, let's see if it's going to let me change colors. There's a couple reasons why. Right there, you've got an exponent that's not a whole number. And right there, you've got an exponent that's a variable. That doesn't happen in a polynomial function. So, not a polynomial function. Okay. All right. Next one, evaluate f of x. Here's the function when x is negative 3. So that's basically just asking you to figure out what f of negative 3 is. So twice that negative 3 to the 4th, 8 times the negative 3 cubed, plus 5 times the negative 3 minus 7. This is not a good time for me to leave my calculator at home. So let me hunt one up. I don't like when I forget mine. I like my calculator the best. Let's see, negative 3 to the 4th. I'm supposed to know that. Nah, it's got to be a positive 81. Negative 8. Negative 3 cubed is a negative 27. Here's a negative 15 minus 7. 162 plus, what is 8 times 27? 216 minus, I can go ahead and put those together. That's minus 22. 162 plus 216 minus 22 is 356. So f of negative 3 is 356. Okay, next one. So we just need to simplify this. We're just taking that polynomial, adding it to that polynomial. So basically, we're just looking for like terms. You have 3 of them here, 1 more of them there. There's 4 of those x cubes. On the x squared, you got 2 of them. You take away 10 of them, that's negative 8 of those. On the x, so that's the only one. And then we got a negative 7 put together with a positive 8. That's a positive 1. That's it. All right, now this time around, we're going to subtract this away from that. So we got to start out with this and subtract this whole 3z squared plus z minus 4 from it. So I'm going to change all these signs because subtract just means do the opposite. And then let's see, 2z squared take away 3z squared. That's a negative z squared. I got 3z's take away a z. That's a positive 2z. And I got a plus 4 on the end. Kind of ran into that. Okay, all right. Finding the product, we're going to distribute 4x to the 5th. Minus, where's the 4 come from? Minus 2x to the 4th plus 5x cubed minus 10x squared, and none of those are like terms, so I am finished. Same thing, we're just distributing. Let's distribute the y first. So just pretend like the plus 5 is not there, and just take and distribute that y. I'm going to get 3y cubed minus a 2y squared plus a 2y. Now, pretend like the y is not there and distribute the 5. Plus 15y squared minus 10y plus 10. Okay, so here's the only cube. Here's some squares. Negative 2 and 15 make 13 of those. I got 2 y's, take away 10 y's. There's negative 8 y's, and then you got a plus 10 on the end. Okay. We're going to multiply this out. So there's 3 different things to multiply. It doesn't matter the order we multiply them in. You just got to pick an order. So I'm going to multiply these 2 first, which is going to give me x squared. Here's a 4x minus an x. So that's a 3x minus 4. And that's getting multiplied by that x plus 5. So now I'm going to distribute the x squared, which will be x cubed plus 5x squared. Now I'm going to distribute the 3x. Now I'm going to distribute the negative 4. So I've got myself an x cubed, x squared. Oh, I don't even have to do that because they're sitting right next to each other. Plus 8x squared plus 11x minus 20. All right, so this one, we're doing a 2v minus 1 times a 2v minus 1 times a 2v minus 1. So if we multiply those two, I'm going to get a 4v squared minus 2v minus 2v. That's minus 4v plus 1. And then let's distribute the 4v squared. It's 8v cubed minus 4v squared. Distribute the negative 4v. Plus 4v plus 2v minus 1. Add our like terms. And then this one, it's kind of one of those where, hey, hopefully this, well, let's see. I'm going to ignore the directions at first. Let's just say you were starting to multiply this. And you're like, okay, let's distribute the 4 in. Distribute the 5. And you're like, oh, those are like terms that just disappear. I've got 16n squared minus 25. Well, look at that. That's the difference, 2 squares. And it turned into 2 things that are, one's a sum, one's a difference. Like, we're hoping that when you recognize that, when it's a product of 2 conjugates, that's when you have the exact same binomial. It's just one's a sum and one's a difference. That always came from the difference of 2 squares. Like, we want you to recognize that as, oh, I know this and this are going to disappear. So, and then this one, we factored enough of those perfect square trinomials to turn them back into this, where we're hoping that you recognize this as well. So, like, if you got a 9y minus 2 times a 9y minus 2, of course, excuse me, if you don't recognize it, it's not like it takes a long time to do this. So you get 81y squared. That's in there twice. But we want you to realize that you square the front one. That's in there twice. 18, 18 is a negative 36 of those y's. You square that back. Like, we're hoping that you just see that and you can go straight there.